Last time we were doing the two-dimensional graph. Can you put that hand out? So two-dimensional graph, you have different definition. Make sure you review that. And we talk about some of the two-dimensional graph, especially we pay attention to the different type of triangles and different type of quadrilateral shapes. Please review them. You need to know the inner angle of triangle is 180 degree. The inner angle of the quadrilateral would be 360 degree. That would be part of the geometry that you need to learn about and review about. We also have another handout last time with the transformation shape, right? Can you find that handout, please? So we're going to finish that part and then we will talk about measurements a little bit more. That is a few terms that you need to know and be able to grab it or like identify the graph related to that. And next week we are going to have one activity for tessellations. For this particular activity, you're going to need to have a pair of scissors, so you can bring paper clips and get a ruler. We're going to need that for a little bit. All right, so we're going to look at these transformation shapes together. There are three terms that you need to have some idea about: translations, reflections, and rotation. So we're going to try to help you to remember those three. We are doing this transformation for the geometry shapes for congruent images, meaning the two shapes are identical. So if you have your pattern blocks, you can pull that out. If you don't have it, that's okay. I'm going to show you here. I'm going to just pick one that we can see easily. When they say translations, because it has S and L here, so I'm going to think about sliding the shapes. Say the equilateral triangle, like this, they are the same shape, right? So I'm going to just slide it up or slide it down or slide on the sideway. I'm not going to turn it, I'm not going to flip it, okay? So just sliding the same shapes of the triangle. I can call this triangle A, B, C, and then just move to here. I'm going to say A pi, B pi, and C pi, like that. Or I can slide down. Sorry, supposed to be the same triangle. A pi, B pi, C pi. So just sliding them around in different area and without turning it or without like flipping it. When translated figures, every point of the figure move the same directions with it. So A move to A, B move to B, C move to C, something like that. Maybe 2 is less confusing. All right, so the second one is reflection. How do we make reflection? Flip it. So this have FL here, so I'm going to say this is representing flipping. If I am using a Y trapezoid, then I can flip it down like this. Is it okay? And then if I have another set of trapezoid like this here, I can flip it to this side like that. Alright, I'm going to draw some for you. I think it's less confusing if I just have two here. So if I have one here for the trapezoid, I can flip it down here. On the test, I may have choices like this, and you have to tell me this is for the reflection. So you don't have to draw it, maybe slightly easier. If we connect any point on the original figures with the corresponding point on the reflected graph, the line of reflection is the perpendicular bisector of the image. So that's why I have the perpendicular bisector here. Are we okay with the reflections? You're flipping the graph. The first one, you're just sliding the graph. What do you think about rotation? What are you going to do? Turn it. So I'm going to use this T to turn. The definition for that is going to be transformation on a plane determined by holding one point, that's the fixed point, and rotating the plane about this point by a certain number of degrees in a certain direction. The fixed point is called the center of the rotation. So if I have one like that, I can rotate it to down like this, like turn it down, or turn it like just sideways, just like this is my fixed point. I can turn it, and I'm just going to move it out so you can see it. That would be considered as turning. And then another one, maybe I started like this, and I can turn like this here, different degrees, so it can be anything, like turn here, turn here, turn here, like so, as long as they have a fixed point and they turn it certainly. All right, so those would be considered as rotations. Turning certain degrees. Are we okay with translation just lighting, reflection just flipping, and rotation just turning? All right, if you're okay, turn to the next page for symmetry. Why do we have symmetry and what is it? Any kind of symmetry here in the room? The lights, okay, yeah, they match both sides. They kind of, if you put a line in between the board, like they have one on each and they're the same size. Sometimes your clothing will have patterns, they are symmetry. And they say the most beautiful people, their face supposed to be symmetrical. For the symmetry, what they are, we have a definition here. The symmetry definition is a transformation or reflection that places the object directly on top of itself. A line of symmetry means that you can draw a line, divide them, and the left side is supposed to be congruent to the right hand side. So the reason we have that is like it creates something beautiful. It creates some kind of order or perfections. Some example, we can have shapes like heart is symmetry, and you can put a line in the middle and the left side should match the right hand side. A circle maybe, a square. A lot of things are symmetrical. We have different kind of symmetry line. We have vertical, horizontal, and diagonal line. Can you give me an example of a shape that has a vertical line of symmetry? A square. They all have it, right? So I'm going to just put a heart there. Can you give me one that's not on the paper? A triangle can work. A triangle would work, but not all triangles. Only the equilateral, right? Or isosceles, right? If it's like all angles are the same and all sides are the same, it's going to be okay. Or if you have the isosceles, which these two lines are the same, then you can also have a vertical one, but not all the triangle. All right, how about horizontal? A rectangle maybe, okay. But that actually also have vertical. It's okay. How about diagonal? A rhombus. A parallelogram. Okay, a parallelogram, can it work though? If you flip the parallelogram like that, are they going to be? So think about if you have a parallelogram, if you have a diagonal line, are they going to match? I don't have a pair of scissors, I'm sorry. Otherwise, I will cut it out and show it to you. This angle is going to be here, so it's actually not going to work. A square, like that, or that. When you flip it, they should match, right? The two sides. So that would be one way to think about it. We're going to have the letter A to Z, and we want to sort them out. Who has the vertical line of symmetry, horizontal line of symmetry, and diagonal line of symmetry? Can we pick one example for each? People can get started. A is what? Vertical. If I have a perfect A, maybe we can make a vertical line of symmetry. How about B? B would be what? We could make a B horizontal, but it needs to be the same size on top and bottom, right? It could be not. If the top part is smaller. Anyone have a diagonal line of symmetry? X? Yeah, X will work. Let's set that. It's a good one. I want you to sort them out. Take a minute. We're gonna check in a minute. Okay, I want you to give me at least 2 more for each. I may help you out with the other ones. People are filling up with the vertical and horizontal, but not the diagonal. There's only maybe 3 of them are diagonal. Okay, can you give me 2 more vertical? How about C? What C is? We could make it horizontal if we draw it carefully. D? We could make it horizontal. Okay, good job so far. E? Horizontal again. Again, you have to draw it to the way that they will flow and match, right? F? Nothing? Okay. F is gone. How about G? Nothing. H? Vertical, okay? It can be horizontal also. And I? Can it be horizontal? Yeah? Okay. Can it be vertical? Yeah. Okay. All right. J? Nothing. K? Horizontal if you draw it carefully. L? Nothing. M? Vertical. Can it be horizontal? No. N? No. I don't think you can fold it. Like if you actually cut it out and you fold it, they will not match on the same place. Okay. O? Yes, all of them. Okay. O, O, O. So it can be diagonal, it can be horizontal, it can be vertical. All right. P? Nothing work. Q? It could be 1. Which one? If you very carefully draw it certain way, huh? Diagonal. Like it could be diagonal if you just cut it there. You have to cut it on that line, then you can fold it. All right. R? None of them. S? Can it be horizontal? If you flow it, it's not going to match. They actually have some brain like games to see which one after you fold it, it will match. It's like luggage, you cannot hit certain place. Yeah, I'm not very good visualizing that either. So when I'm not certain, I may cut them out to make sure they fold and do they match both sides. Okay, T, vertical. U, vertical also. V, vertical again. W, yeah, if you draw it correctly, carefully, you can fold it vertically. X, I heard all different things. Which one? All of them. It can be vertical, it can be horizontal, it can be diagonal. Oh, where do you have it? Y, vertical. Z, none of those. Okay. Do you get an idea how that works? Okay. All right, so the last page talk about tessellation. Anybody know what tessellation is? No? Tessellation is when you use the figures and or combination of figures, tessellate the plane in a regular repetitions of the figures, and the figures will cover the space that there is no gap, no overlapping. We don't really care about if the edges are smooth or not. So we are repeating some shapes or a combination of shapes. Make sure there's no gaps and no overlapping. Some examples, if we put tiles, square tile, rectangular tile on the floor or on the ceiling, there should be no gap and no overlapping, right? Square will work, rectangle will work. What else? How about triangle? Will triangle work? Yes. So you can have triangle and triangle, same shapes, keep repeating like that. If you have your pattern block, you can try it at home. Triangle is okay. Give me one more. Think about your pattern blocks. What else can work here? Will hexagon work? Yeah. And some of the tile look like that too. It's harder to draw, but they will work. I'm doing my best, okay? Something like that, so you can repeat and you can cover the space. There's no gap, no overlapping. So this guy will work too. The question is, will all triangle and all of the quadrilateral tessellate? and Y. We learned about triangle, we learned about the quadrilateral shape, four-sided shapes. Will all of them work for tessellation? Any random shape? Did you say yes? You didn't say yes. She's not committed to yes. Anybody have any idea? Will that work or not? Quadrilateral and triangle, will they all tessellate? Yes, why? She sounds very confident. Because, say if I have a shape like that, or a triangle like that, or a triangle like that, or I don't know what other four-sided shape I can have. Have to be four-sided, sorry. Like, so random four-sided shape or random triangle, will they all tessellate? I have one note. It has something to do with the inner angles, because they're supposed to add up to what? For triangle, the inner angle sum of, I'm having problem put this sentence together, equal to 180, right? And then for the quadrilateral, for the four-sided shape, you have what? We did that last time. The inner angle equal to what? 360. Two triangle, right? They can cut the two triangle, right? And in order to fill all around, that would be how many degrees to fill all the, like a circle? 360. So because both of them can add up to 360 somehow with the angle, so they will all tessellate. And the activity we wanted to do is going to be trying to show you why they would tessellate. So we know triangle add up to 180. We know the quadrilateral add up to 360. If you have two triangles, you can make 360 anyway, right? So somehow they can reach to 360 degree, which is like an angle. Sum of all of them, which is like a round circle, cover everything shaped, will be 360 degrees, so they can fill up all the gaps. In general, all the triangle and all the four-sided shape, which is quadrilateral, is going to tessellate. Besides that, we're going to do a little bit measurement activities. I should have started with that for the geometry, but I need to show you all the homework question first. So the order is a little bit off. What I'm going to do next week for the activity, it will look like that. I will give you a little square shape like this, and you will just, draw some random shapes and tape it together to the other side. So this shape is coming from a quadrilateral, and then it's going to show that it's going to tessellate, because somehow they will add up to 360 degrees. That would be the activity. We want to prove to you that any four-sided shape is going to tessellate. If you can, bring some scissors. I will bring tape. All right, we haven't really touched on one of the things that we have to talk about, which is measurement. What is measurement and what do we use to measure? Long time ago, when they tried to do things like making clothing or building a bridge between two cities, or there's a king want to build a bed to sleep on, they have to tell somebody else how big or what size something need to be, right? So they start doing some measurements. Long time ago, the king is going to try to use his arm or his feet to measure certain things. That's why we say how many feet is somebody's feet, okay, at the beginning. So everybody grab like a paper clip, right? We're gonna start with what long time ago happened with measurements. We want to start with something not standardized for measurements. Everybody have a paper clip? We can use a paper clip. And how many paper clip is it gonna take to measure the length of your pen or pencil? So I want you to take a minute, just check how many paper clips does it take to measure your pen or pen. It may not be one whole one, right? How many paper clips is the length for your pen? How many paper clips is the width of a piece of paper? So measure these two things for me using your paper clip, which I assume some of you get a bigger one, some of you get a little one. You're gonna start with the edge, and like this is one paper clip, 2, 3. How many for you?
3.
Just 3? Oh, because you have the big one? Is that what it is? Yeah, that's about double the size. So for me, I say 6 paper clips. And then some of you say 3 paper clips. That is the problem, right? Because we don't have a standard measurement. So we're going to come up with different ideas. So the king may say, okay, I need 10 feet for my bed. But then the person making the bed may have much smaller feet. So the bed is not going to fit, right? When we don't have standardized measurements, it's going to be a problem. So let's do just one more. I'm going to need somebody relatively tall to come up here and somebody relatively shorter to come out here to help me. Just going to measure how many feet from here to there. Maybe somebody shorter here. So just count like how many feet you need to walk to the other side from this side to this side. So do the edge and then. Number 3, we were asking students use foot to measure the width of the room. We have one with 20 feet. How about you? 20?
It was like, I had like a little bit.
Okay, so 20 plus feet. So they're not that different, but it may not be like standardized. If it's like a much bigger area, so if you're trying to build a bridge or something, that may be a problem. Like it may not reach the other side. The people who measure it with like a smaller feet. How about paper clip with your paper here? Just do one more. Anybody have a number for the paper clip to measure your width of your paper? 9, I heard. 4 if you have a very big paper clip. So, and depending on your paper too, some of you have a bigger piece of paper, I have smaller. So the number will be all over the places, right? So that is the reason why we need to use standardized units, right? That's why we use standardized units with rulers, etc. But you can start with the not standardized type of measurement with children. That would make sense to them why we are measuring and how we started measuring things. And it's interesting because sometimes I go to other countries to visit my friends and they use different kind of units, right? They can ask how big is my office and I can tell them it's about the size of their master bedroom. So we can have a mutual understanding of the size even though we use different kind of units to measure area. So even though sometimes it's non-standard kind of measurement, it will help us to understand the idea better. So everybody grab a ruler now. If we actually measure the pen or pencil that you have, because some of you have pencil, probably will be shorter. I want to know how many centimeters. So make sure you start from 0 to the actual measurement. I have 14 something, 14.4 centimeter. The actual one. Anybody have a different number? No, about the same. Once we use the standardized type of measurement, it's easier to figure out. How about paper? From 0 to, make sure you're using centimeter. What do you have? Centimeter, how many? 23 I have. If you have bigger piece of paper, maybe 23 centimeters. Somebody have a smaller piece of paper? I have less than 22, so mine is 21.9 centimeter. Sounds about correct. And if we actually measure the room, then we will have a standard one, right? Okay, so what kind of question should we ask when we are measuring something? The question would be maybe how tall is somebody? What else? How measurement? How many? I don't know. How tall is your height? How many is like how many items, or measuring speed we use what? How fast. Measuring length can be how long. Measuring your weight we can be how much, okay. Measuring your dog's weight maybe how heavy is the dog. Measuring distance, about. So those are questions related to measurement, right? But when we measure something, there are several things we need to know when we do measurements. We need to know what do we want to measure, what units to use to measure. Even we have the ruler, we can use either centimeter or inches, right? So we need to understand which units we are using and the amount we have in terms of unit chosen. Then we are going to look at some of the standardized units. I gave you some handouts, so we will take a quick look for that. We have volumes, we have capacity, we have weight, and we have mass. So those are related but get confused quite a bit for students. When we talk about volume and capacity, the volume is measuring something dry, like flowers, sugar. I mean, you can use weight also for them. But capacity would be something wet, how many cups of milk, or like how many gallons of something. The weight and mass are different because weight could change if you are on Earth or in the space. The weight is not going to be the same. The mass is the same no matter you are on Earth or space. We just do something very basic about this information. There are two handouts. One is for the conversion, one is something with pictures. The one with pictures, so I know the handout is not very clear. It's probably 10 years old, and that thing is not online anymore. I cannot find it again. They're probably charging money nowadays for you to use it, so I can't access and get a new one. But I think it gives you some good idea, and that can help children remember some of the measurements. They say between your knuckle and your index on your index fingers. The distance between knuckle and your index finger is approximately 1 inch. Can you go ahead and try to measure it? For adults, I guess they have to specify for like index finger. Sorry, this one. Sorry, you're right. Index finger. I was pointing out to the middle finger. So this is actually more accurate. It's more closer to 1 inch for me. Is it for you? Like index finger, just like between the knuckle, like this part. Is it 1 inch? Okay, so that's a good one, right? For your notebook, it's approximately 1 foot tall. So any standard notebook is about 1 foot. If you put your feet on it, it's about that too, okay? And then your baseball bat is about 1 yard. That one is hard for me because we don't use yard growing up. And then the long distance are measured in miles. The distance of vehicle travel is measured in miles. So you can think about like if they're driving 60 miles per hours, then each minute they drive about 1 mile. So that's the way I think about it. Okay, centimeter, the width of your index finger. So I'm pointing the right finger this time. Is it about 1 centimeter? Let's check it out. The width of your index finger about 1 centimeter is close. It's not exactly. So that gives children a better idea with the measurement, I think, visualization. We don't use that very much, but a meter is about the distance from the floor to the doorknob. A kilometer is going to be the length of 6 city blocks. Is going to be hard for you to think because we don't walk that much, but that's what they have. Okay, an ounce is about a slice of bread, so that would help students to understand like how heavy that is. A pound, you can think about a loaf of bread is about a pound. A ton is going to be a lot, right? So we used to measure heavy things such as a car. A gram is like a pack of sugar, maybe 1 gram. And then a book weight about 1 kilometer, so that's 2.2 pounds. And a car weighs about 100 kilograms. Okay, capacity here. So they're sorting them as length, weight, and capacity. The capacity is the wet stuff, right? So a small cup is going to be about 1 cup. And then a tall glass of lemonades or a bowl of soup would be about 1 pence. If you have a car and you do your oil change, the oil come in the quart size container, so that's 1 quart. And if you drink milk, that's like a gallon. A milliliter is like a drop of medicines, and a liter is 1,000 milliliters. So some of the soda or drink will be in liters, so you can check that out when you get a chance. On the back, it has story about, and that's supposed to help you to remember the metric system. I know it's not very clear. Would somebody be very kind and read this out for me, please? Loud and clear. Tell me the story. What is it? Somebody help me to read the story out loud.
As most of you are aware, England has used metric for a long time. At one point in history, King Henry was on the throne. He was having such a time with measurements and kept getting all mixed up when he tried to change from kilometers to meters or meters to millimeters. He became frustrated that there was not something that he as king could not master. He called the greatest mathematician of the time,
Usually.
who explained to King Henry that in metric you are always multiplying or dividing by powers of 10, which can be accomplished by moving the decimal. With this knowledge, King Henry devised a chart that worked perfectly for him. He decided to test these charts on the people of his kingdom. So King Henry took his chart and walked down Central Main Street, trying his chart on everyone he saw. As each person he met easily learned his system and mastered the chart, he became so excited that the King Henry danced merrily down Center Main.
So they're using this sentence to help you to remember the order of them. Start with kilogram or kilometer, start with K. Henry is the hectare, which we don't use a lot. And D is decker, and then meter is merrily. Down is the decimal. Center is the centimeter, and the main is the miller. So like you can use the sentence to help you to remember the order of them, and they change it slightly to help. And for each one you go up or down, you just move one decimal place because they're base 10 and 10 to some power. So it's a lot easier than the system that we have. So that's all I have today, but what do I need you to do? I need your homework for sure. Please start studying all the geometry material. You have a quiz coming up